Okay, here is the next example. A woman 1.6 meter tall stands in front of a vertical plane mirror. So here is the mirror. Okay. What is the minimum height of the mirror and how close must its lower edge be to the floor to see her full image? So we want to see her full image so the top is right there, bottom is right here. And so the question he's asking about, what is the h value and what is the d value, and he gave us the total height of the person, which is 160 centimeter, and they also mention the eyes are 10 centimeter below the top of her head. Now all we know is law of reflection. So we know that law of reflection is theta I equal to theta r. Okay, angle of incident equal to angle of reflection. Now, so first we'll look at here. So the light ray must, the light ray must pass in this way. So basically the light ray must reach in that direction. So all we know is theta I equal to theta r. This is normal. Okay, so I know that theta I must be equal to theta r. So if we look at this triangle, so the height from eyes to the toes is 1.5 meters. So if we make theta I equal to theta r, isn't it going to bisect exactly in the middle, which is 0.75 meters? So can I say this height, the d must be 0.75 meters. Now we'll look into the top portion. So if you look into the top portion, here is the top of the head and here is the eyes. So a light ray has to, let me draw it here. So here is theta, the light ray is coming back, but the light ray is going to fall there. So I'm going to magnify that portion. So here it is. So theta I must be equal to theta r. Okay, this is the light ray. Okay, and that's the normal to the mirror, and this is the top portion of the mirror. Okay, all I know is only this height. What is that height? That height is 10 centimeters. Okay, so if that is 10 centimeters, can I take this as this height must be 5 centimeters, right? I'm talking about this height. I didn't draw exactly, but so this must be 5 centimeters. Okay. So the total height of that person is 1.6 meters or 160 centimeters. Okay, so here you're going to place the mirror somewhere there, and I know this value I end up with 0.75 meter, and this value I end up with 0.05 meter, because that's 5 centimeters from here. So can we tell what is the height of the mirror? So height of the mirror must be 1.6 minus 0.75 minus 0.05. I'll end up with 0.8 meters. So that's the height of the mirror. Now the next topic is refraction. So not every material is going to reflect the light ray. Some materials, they allow the light rays. Say for example water. If you take a water, if a light ray fall onto the water, okay, what it will do, instead of reflect, it will refract, it will pass through the water. Okay, so light ray is going to pass through the water. Now here I'm going to take theta 1 or theta I as angle of incident. Now theta 2, I'm going to take that as angle of reflection. Angle of refraction. Now what happens when it is passing through one type of material to another type of material? The speed of that light ray is going to change. Okay, so how that speed is going to, how can we determine the change in that speed? We can determine by using index of refraction. We call that as index of refraction. Okay, we indicate with the small n. So the index of refraction indicates it's a number. That number is nothing but it is defined as speed of light in vacuum over speed of light in given material. Okay, n value is speed of light in vacuum over speed of light in given material. So this n value is always greater than 1, because speed of light in vacuum is the highest, which is 3 times 10 to the power of 8 compared to any other material. So the n index of refraction, which is speed of light in vacuum over speed of light in given material. So for that given material, n value is already given. For vacuum, it's always 1, air 1.003, but in this class we're going to take it as 1 is accepted. Okay, water is going to be 1.33, oil is 1.46, glass is 1.5, plastic 1.59, sodium chloride 1.53, diamond 2.41, silicon 3.5. It's a constant. So basically what I'm saying, the speed of light in vacuum is 3.5 times more than the silicon, and speed of light in vacuum is 3 times 10 to the power of 8 meter per second. So from that C value, you can find the speed of light in silicon. Same thing with water, oil, and glass. So far we learned refraction. Refraction is nothing but some materials allow light passing through them. So those material, instead of reflecting, it is refract. It's going to pass through those materials. So theta 1 is angle of incident, theta 2 is angle of refraction. From that, I also define index of refraction, which is n value. It indicates the speed of light in that given material. From this, I'm going to define new law called Snell's law. According to Snell's law, n1 sine theta 1 equal to n2 sine theta 2. So here n is the index of refraction. Okay, so n1 is the number first material, 2 is the second material. So n1 is index of refraction in material 1, and n2 is index of refraction in material 2, and theta 1 is angle of incident and theta 2 is angle of refraction. So Snell's law is nothing but n1 sin theta 1 equal to n2 sin theta 2. n1 is index of refraction for material 1, theta 1 is angle of incident, n2 is index of refraction for material 2, and theta 2 is angle of refraction. Now I'm going to solve a simple example. Here is an example. here is a material, a glass material. N value for that glass is given. Okay, N value here is N equal to 1.5. Now a light ray is falling onto this glass material with an angle, it's not angle of incident. He gave us the angle 60 degrees, because angle of incident is nothing but angle between the glass, normal to the glass. This is normal to the glass, and the light ray. So theta 1 is right here. What is theta 1 in this case? The normal to the glass and angle between the glass and normal to the glass must be 90 degrees. So theta 1 must be 30 degrees. Now what happened here, according to Snell's law, n1 sine theta 1 equal to n2 sine theta 2. So I know n1 value. Here it is air. I'm going to take that air value, n1 equal to 1. So in the future, definitely I'm not going to give you n1 value for air value. Always take it as 1. So 1 sine 30 equal to 1.5 sine theta 2. Okay. So from here I end up with the theta 2 equal to 19.46 degrees. Okay, so theta 2, the light ray is going to bend towards normal. 19.46 degrees. So the one important thing I want you to notice here, when the light ray is traveling from a thin material, n is 1 here, n is 1.5 here, so I'm talking about thickness. So if a light ray is traveling from a thin material to thick material, then the light ray is going to bend towards normal. Okay, towards normal. Now from here, here is another normal. Our goal is, what is this angle? Theta x equal to how much? So once I know theta 2, can I take this this angle also same as 19.46? Okay, so n2 sine theta 2 equal to n3 sine theta 3. n2 I know, which is 1.5, sine theta 2 is sine 19.46, and n3 is 1 and sine theta 3. So find the theta 3 value. Okay, so from here sine theta 3 equal to 0.5, so theta 3 equal to 30 degrees. I'll solve more examples in the next video. Thank you.